Hey guys, Mr. Backerberg here. In this video, we're going to look at second derivatives and other higher order derivatives. So as we're looking at derivatives, the derivative y prime equals dy over dx is called the first derivative of y with respect to x. But sometimes that first derivative function that you end up with is also differentiable. If so, then its derivative, or y double prime, is the derivative of dy dx. So this is called the second derivative of y with respect to x, or we can call it y double prime. And then sometimes even beyond that, sometimes that second derivative is also differentiable. So then its derivative would be the third derivative of y with respect to x, or we could call this y triple prime. And this process continues. For certain functions, you can take higher and higher derivatives. It just depends on what function it is that you're dealing with. So in this example, we're going to do some higher order derivatives, and we're going to find the first four derivatives for the equation y equals x cubed minus 5x squared plus 2. So as far as the first derivative goes, we're just going to apply the power rule. So for the first term, I drop the 3 down in front, and then I subtract 1 from the power. For my second term, I'm going to drop the 2 down as a multiplier, multiply that by the negative 5 that's in there, and it becomes a negative 10, and then subtract 1 from the power. And then on the back end, when you differentiate that constant, it's just 0. So this is the first derivative. Now if I want to take the second derivative, I'm just going to differentiate that function that I just came up with. So again, applying the power rule, drop that 2 down as a multiplier, and this becomes 6x. And then on the back end, if we drop the 1 down as a multiplier, and then subtract 1 from the power, this just becomes minus 10. So there's your second derivative. Now we can also do the third derivative, again, by using that power rule. So here on this x, if I drop down the 1 as a multiplier, but then subtract 1 from the power, that just goes away. When I differentiate that constant, it just turns into 0, so I don't really need it. So the third derivative is just 6, but then if I want to do the fourth derivative, when you differentiate a constant, the answer you get is just 0. So there are your first four derivatives for this function that we were given at the beginning. Now realistically, we could keep going with this. We could do a fifth derivative or a sixth derivative or a seventh derivative, but any derivative after this fourth derivative is still going to be 0. 0 itself is a constant, so when you differentiate 0, you still get 0 as the answer. So everything past the fourth derivative for this specific function is just going to be 0. So we don't typically talk about those other higher order derivatives. That's going to be it for this video. Thanks for watching.